Hello class, in this video we shall be discussing about the size of octahedral void in relation with the radius of atoms in the closed packing. Let us first try to know how these octahedral voids are formed. Okay, octahedral voids are formed in the centers of 6 spheres. That is, as you can see on the board, these are suppose the 6 spheres. So the space or the void formed in between these 6 spheres is the octahedral void. Okay, now moving on to the next part, that is here in this diagram. Suppose the distance, or say like a unit cell, okay, present at the corners of the unit cell. Okay, now the edge length of this unit cell is suppose A, and this distance are R. Okay, then what happens? The value of A is equal to 2R, isn't it? That same way here also, see this octahedral, for these 6 spheres, if we try to fit in this cubic unit cell, okay, then it will give a face centered, okay, cubic unit cell, that is like this, where the atoms are present at the 6 faces. Okay, centers of 6 faces. One is here, the other one is here, and here, and here. Now, as you can see, okay, see these 4 atoms on the horizontal and 2 atoms above and below. Okay, so here, see, suppose whatever atoms are present here at the corners, it will be the same size that is available even in the face centered. So what happens? The distance between any 2 close atom, okay, any 2 adjacent atom will always be 2R. Yes or no? And that 2R is the edge length of the unit cell. Okay, so that's why here also the distance between any 2 adjacent atoms will always be A, okay, which is the side of the or edge length of the unit cell. Okay, so moving on to the next part, okay, that is, let A, okay, this is the main part. Earlier it was just a brief explanation about how these octahedral voids are formed and how it will be, okay, A equals to 2R. Okay, so now the main part is here. Okay, you may start writing from this part onwards. Okay, so let A be the edge length of the unit cell. Okay, okay, right here, R be the radius of atoms, and small r, okay, be the radius of octahedral void. Okay, so this is it. Now in this case, see, since a full octahedral void atom, say suppose an atom is there, then if its radius is R, then diameter will be 2R, isn't it? Okay, now next part. Okay, see here we are trying to find out the value of R. Okay, but in order to make it more simpler, what we do is we try to relate the small r with the capital R, that is the radius of the atoms, and that way we will find out like by how much amount or by what factor the size, okay, by how much factor the size of the octahedral or the radius of the octahedral void differs. Okay, so now let's take like this in triangle ABC. Okay, So here let us try to find out AC. Okay, AC equals to, see, this one also will be A only, isn't it? AC equals to root over AB square plus BC square. Okay, so AB, say suppose now we take in terms of A. Okay, in terms of A, so that is A square plus A square root, then AC equals to root over 2A square, so which will be equal to root 2A. Okay, so AC is equal to root 2A. Then the next one is AB. Okay, AB or BC. Okay, so AB is equal to, if it is in terms of A, then we write equals to A. Okay, now we try to divide them. Okay, we will try to divide this equation, okay, this AC and AB. Say suppose equation 1 and 2, dividing equation 1 by equation 2. Okay, dividing equation 1 by equation 2, so that is AC by AB equals to root 2A by A, so we get root 2. So that means the ratio, that is AC by AB, is equal to root 2. Now the reason why we are taking AC by AB is because you see, along the AC we will be getting, along the AC the octahedral void is present. Okay, and along AB or BC or this other side, the atom, the radius of atoms can be found. Okay, now in relation with these two, we will eventually get the value of the octahedral void. Okay, so okay, I think you will understand in the next part. Let us go ahead. Okay, so this was in the form of A. Now we shall take in the form of R. Okay, R. Okay, that is, see, AC equals to R plus 2R plus R. So this will be equal to 2R plus 2R. I can also take common, that is 2R plus R. Okay, now the next one is AB. AB equals to 2R. Okay, so this is AC, that is this one, and AB is this much. Okay, now again we take AC by AB like this one. Okay, so AC is 2R plus R and AB is 2R. Okay, so 2 gets cancelled, we get R plus R by R. Okay, okay, now let me just write down here. Okay, so AC by AB is root 2. Okay, so this one, say this is equation 3 and this one is equation 4. So comparing equation 3 and 4, we find out that left hand side is same. So okay, comparing equation 3 and equation 4, we get R plus R by R equals to root 2, isn't it? So R plus R equals to root 2 is 1.414 R. Okay, so R equals to 1.414 R minus R. So R equals to, it would be 0.414 R. Now this is the final answer. So here we can find out that the radius of the octahedral void is 0.414 times the radius of the atom. So that means if we know the value of the radius of the atom, okay, then we will eventually know the radius of the octahedral void as well. Okay.